So let's look at number 6. Calculate the molar mass of each compound. So this is finding the mass of 1 mole of this compound, which means we have to look at the formula and do in our head what we did for problem 5 and see, well, how many moles of copper are in 1 mole of this? How many moles of hydrogen? How many moles of sulfur? How many moles of oxygen atoms are in 1 mole of this formula? And then the mass of each of those. So for this first one, there's 1 copper in this formula. And copper has the molar mass 63.55. So we have 1 times 63.55. In 1 mole of that compound, there's 1 mole of copper atoms. There are 2 moles of hydrogen atoms. The hydrogen is inside the parentheses. There's a 2 on the outside. There are 2 moles of hydrogen, and so we need 2 times the mass of a mole of hydrogen. How many sulfurs are there? 2. And sulfur is 32.07. And how many oxygens are there? There's 8 oxygens. And each of them is 16. So we're taking that formula and seeing how many of each piece are there, and what do those pieces weigh, what do the atoms weigh, and then we're adding them all up. And we're going to round this off to 4 sig figs because that's what we rounded all the molar masses to, so 257.7 grams. And that is equal to 1 mole of this compound. That's what molar mass means, the mass of 1 mole. So 257.7 grams is the molar mass. Any questions? Let's look at number 7. Determine the number of moles in each sample. So here we're given 36.5 grams of sulfuric acid, H2SO4. So we want to multiply by moles and divide by grams. That's what the units tell us to do. But we need to know the relationship between grams and moles. The relationship is the molar mass. We just practiced calculating that. So in H2SO4, in 1 mole of that, we're calculating the mass of 1 mole. There are 2 moles of hydrogen atoms and 1 mole of sulfur atoms and 4 moles of oxygen atoms. .09 grams equals 1 mole. So 1 mole weighs 98.09 grams. So we take 36.5, divide by 98.09, and that will equal 0.372 moles.